Okay, so let's try to do number 13. So it says we've got carbon-14 dating. Then it says, okay, carbon-14 decays continuously at this rate of horrible, scary number. And then it says an archaeologist has determined that 5% of the original carbon-14 from the plant remains. Estimate the age. Cool. This is actually how carbon dating kind of works. Pretty fun. So, what's the model for this thing?
It's like what the entire growth and decay thing. Well, not decay yet. The growth. I guess we're working on. The
Yeah.
chemicals, yeah.
It's the PERT model, right? It's the continuously compounding thing. So my model is kind of this P of T is P naught e to the RT, right? Okay, and what's the population I'm talking about here?
14.
Yeah, I'm talking about the number of carbon-14 molecules, right? And they're not increasing, they're decreasing, but it turns out that this thing doesn't really care. Cool. All right, so I've got my model written down. Now I'd like to know about plugging some pieces into it maybe, right? Okay, so how do I plug some pieces into this thing?
Well, for the rate, would it be negative 0.01245 or because yeah.
Okay, so I want to think about this rate, right? I've got a rate of blah blah percent per year, right? Okay, see that? That's a decay, so I need a negative sign, which Kevin very astutely spotted, right? And that's, ooh, that's kind of a funky number, right? Okay, so let me see. My P of T is just the rule's name, right? So I'm going to leave that thing alone. Right, I just named my rule P. It takes teeth. And then, okay, this is equal to, all right, so I don't know about that first thing yet, but E, there's going to be a T. And what was your observation of the R?
Since it's decaying, it would be decreasing, so that
Okay,
percent
so
would
it's
be negative.
negative. I'm with that. Then what?
Well, we're going to make it into a decimal form, like percentage. There's going to be a lot more zeros in, or is it already down enough?
No, you're right. So this thing's a percentage, right? Okay, see that? I have to make that into an actual kind of decimal rep. So I make that, what, point, which way does it go when I'm moving percentages to decimal?
To the left.
Okay, so what do you get? Point,
0.0001245.
very nice, 0.0001245. And then that's multiplied by T, right? Okay, now what's the amount you started with?
Would it be 100%? You started with there being 4 carbons, so.
Okay, we could say 100. And then our units are,
Percent.
yeah, percent of what we started with. That's okay? We could actually just stick some dummy letter in here, like P0, and we could still work with this problem. Okay, but it's easier usually for us to stick a number in there. So maybe we start with 100, or we start with 1, and then my units are the whole thing, right? The amount of carbon you started with. Now I'm working with percentages of the amount of carbon you started with. Similar but slightly different. How do I answer the question?
Your salt, so you want to set the left side equal to 5%.
Okay,
So
so
So it should be like 0.05 equals whatever our POERT is, right?
Equals this thing.
And then solve for t.
Okay, so remember that 5% of the original? What is that in terms of this guy? Well, these guys are in percent of the original, right? So here I'm not looking for 0.05, but 5. Does that make sense?
Yeah.
I've got to make those units agree. Notice that I'll see the 0.05 here in just a second when I what? What do I need to do to solve this for t?
Divide by 100.
I need to divide by 100. Oh, there's my 0.05, right? So if I had started talking about the whole thing and put a 1 here, then I would have a 0.05 on the other side. Okay, so now what am I doing? What should I?
Should get the natural log, so I can remove the e.
Yeah, I'm trying to find t, right? So I should dust off my natural log. Hit both sides of this with that thing. So I've got log of 0.05 is what?
Negative 0.000145 t.
Very nice. So get this, then what do I do?
Divide by the negative point, yada yada yada.
Okay, so we could divide by this negative 0.000125, or we could get a decimal for that and then divide either way, right? What do you guys choose to do?
I'm just using the dividing version and solving it out.
Okay. So if we divide first, we get t is ln of 0.05 divided by minus 0.000125. Somebody give me a dealie on that? Almost there. That's scared to death.
Yeah, I don't know.
24062.
Say again?
24062.10661.
24062.
0.10661.
Whatever, right?
You're talking in years, it doesn't.
Yeah, so I'm talking in years, right? So my answer is like 24,000 years. Am I likely to care about the 0.106? Probably not,
If
right?
you're comparing two things that are really close together and you want to see which one's slightly older than that.
Yeah, this
Most
is
of
a
the time,
shitty
no.
test for slightly older.
Yeah.
This thing's a really nasty ballpark anyway, right? Because I really ballparked basically everything here. I started with this model, which is only a model, right? It's not actually the truth. And then I started rounding later. You guys see that? So I think calling this 24,000 is probably pretty good. And the error bars on these things are pretty big usually. So if we wanted to answer our question in terms of what? How should I answer it? Yeah, oh, they asked in words. I should probably respond that way. So what do I say?
About 24,000 years.
Yeah. So it's about 24K years.